How do we know if we're using the correct formula for a question? Well, we can use dimensional analysis. There are three main things we can use dimensional analysis for. One is doing unit conversions, another is verifying an answer in a calculation, and a third use is verifying a formula to make sure it's correct. Here we'll look at using dimensional analysis to verify a formula. LED, or light-emitting diode bulbs, are much more efficient than older incandescent bulbs. This 8-watt LED bulb produces as much light as a 60-watt incandescent bulb. The number of watts a light bulb consumes is called its power, which is symbolized by a capital P. In electricity, power in watts is related to current, which is symbolized by a capital letter I, and measured in units called amperes, and voltage, which is symbolized by a capital letter V and measured in units called volts. We'll relate all of these quantities in a table, but before we do that, we'll just explain a couple of terms. A joule is just a measure of energy. Here we're using it for electrical energy, but it can be used for any form of energy. A coulomb is the electrical charge carried by a large number of electrons. In our discussion, it's easier to think of a coulomb as simply a large group of electrons. In this table, we'll explain a little more about the quantities of current, voltage, and electrical power. We'll start with current. Its symbol is a capital I. Electrical current is the rate of flow of electrons in an electrical circuit. The unit used for current is the ampere. 1 ampere is defined as the rate of flow of 1 coulomb of electrons per second. Now we'll look at voltage. It is symbolized by a capital V. Voltage is the energy carried by the large group of electrons that we call a coulomb. Voltage is measured in units called volts, which is reasonable. 1 volt is defined as 1 joule per coulomb. With 1 volt, each coulomb of electrons carries 1 joule of energy. Finally, power, symbolized by the letter P, refers to the rate that electrical energy is used in a device like a light bulb. Power is measured in units called watts. 1 watt is defined as 1 joule per second. A 1-watt device will consume 1 joule of energy each second. Let's say we can't quite remember which formula we need to use to calculate power. Is it P equals I over V? Or is it P equals I times V? No fear, dimensional analysis will come to our rescue. Let's see what happens with our units if we use the first formula, P equals I over V. Here we don't need to use any actual values, just the units. I has the unit coulombs per second, and V has the unit joules per coulomb. Coulombs per second divided by joules per coulomb is the same as coulombs per second times coulombs per joule. Remember, dividing by a fraction is the same as multiplying by its reciprocal. So dividing by joules per coulomb is the same as multiplying by coulombs per joule. Multiplying the units coulombs per second times coulombs per joule gives us the unit coulomb squared over second joule. And this unit definitely doesn't make sense as a unit for power. So the formula P equals I over V is not the correct formula for power. Using the second formula, P equals I times V, we get P equals I in coulombs per second times V, which is in joules per coulomb. This time we multiply the units coulombs per second times joules per coulomb. Notice the unit coulomb is on the top and on the bottom, which means we can cancel it out. And we're left with the final unit, joules per second. And joules per second is the correct unit for power, which means the formula P equals I times V is the correct formula for power. We've seen that dimensional analysis is a powerful tool. It can be used to check a formula using just the units for the quantities, and not needing to use any actual values for these quantities.